Good morning, everybody. Welcome to another beautiful Science Saturday. You can see my background is different today because I am on St. Croix. Yay! I love St. Croix. I have eaten so much in my past few days here. Just a little bit because I'm so excited. Yesterday we had our World Oceans Day cleanup in Frederiksted and it was so much fun. So even though that's not a Science Saturday event, I am so excited with all the support that we got from the community. So thank you to everyone who came out to Frederiksted for the World Oceans Day cleanup. So today for Science Saturday, we are talking about coral. Again, you know we love coral at Science Saturday, but we're here at the Nature Conservancy in Estate Little Princess, and we're going to be looking at how they are essentially growing coral and taking care of coral, and they have a beautiful brand new facility where they are doing all sorts of amazing stuff that I'm not going to talk about because I am not the expert, but I am here to enjoy it and watch it and learn so much. So, first of all, I don't know how much you guys can see behind me, but it is beautiful here. I absolutely love coming over here. So we are going to walk over to the water tables and flip camera to Lisa. Good morning.
Good morning.
So, who are you? Where are we? What are we doing?
My name is Lisa Terry, and I'm a coral biologist and conservation practitioner here at the Nature Conservancy. And this is our Coral Innovation Hub, where we have raceways where we'll be growing corals on land to complement the corals that we're already growing underwater here in St. Croix.
So this is a new project, but it's supporting stuff that you guys have already done.
Absolutely. We have been growing coral here in St. Croix and also in St. Thomas since about 2009.
Okay.
And that has mostly been underwater, so requires a lot of scuba diving and working with very specific species, some branching corals. And what we're doing now is moving into working with other species, and some of the bigger bouldering species that we want to grow are not as easy to work with underwater.
Okay.
So if we can bring them into the lab and we don't have to be wearing a tank and scuba gear to work with them, it gives us a lot more opportunity to work with those bigger species.
Right. You look very comfortable today in your awesome TNC shirt,
Yeah,
by the way.
exactly.
I'm really jealous as I'm like rolling up the sleeves on mine to try to beat the heat. So before we start with like the details of what exactly you guys are doing here, why are we growing corals? Why are we doing this above or below the water?
Yeah, so corals have had a tough run for the last several decades. There's a lot of things that are threatening coral reefs. Things like land-based sources of pollution. Probably the number one is climate change affecting our corals. Additionally, now, as you maybe have talked about in other Science Saturdays, we've got a pretty vicious coral disease that's hurting a lot of corals in the Virgin Islands right now.
Guys, remember we talked about the science of coral disease and then we did the disease wheels. That was rough. That was sad. It is still sad.
Yeah, so we also really recognize the importance of corals. We think that corals, being the backbone of our reefs, provide us with a multitude of resources, including a source of food, including shoreline protection that protects us from those storms and other effects from climate change. So we want to make sure that corals stick around for a lot longer. And so our sort of part to play in that is to work on dialing in the science of coral restoration.
Okay.
And I think this lab is a pretty important step. So
yeah, I mean, just a quick little look around. I mean, there are lots of tables, but the science and the engineering behind this is amazing.
Yeah. So at this facility, we do have 24 raceways that we can grow corals in. We also have a dry lab where we can set up microscopes and perform experiments. And we also have a wet lab where we'll be building smaller raceways, smaller tanks to do more specific experiments and controlled conditions for corals as well. So
very cool.
A lot of opportunity here to do some really good science and figure out how to scale up coral restoration.
Awesome, very cool. So where are we gonna start our adventure today?
So today we're going to talk about cutting up corals into tiny little pieces.
It sounds so like terrifying,
Yeah.
but it's awesome. Promise,
Yeah.
guys, it's awesome.
Yeah, so actually one of corals' main ways to reproduce is by fragmenting themselves into pieces. Some coral species do this more willingly than others, but all corals can break into a different piece and continue to grow as individuals.
Okay.
So we utilize that in our coral propagation, and we use a technique that has been referred to as microfragmentation.
So, like, such a buzzword on Facebook. I know that everybody has watched, one of 5 videos about microfragging. And one of the reasons I was really excited about coming here today is that we're doing this now. Like, in the territory, it's going on. So we don't have to look to the States. We don't have to look to other places. It's happening here. We're doing it, guys. Well, I'm not doing it. Lisa's doing it, guys.
Yeah, definitely. So today we're actually going to give you guys a demonstration of cutting up some corals into tiny little pieces. But real quick, just to kind of take you through the process before we start cutting corals.
Yeah.
You want to come around to this thing?
I'm coming.
So in order to start this, we have to actually bring corals in from the ocean. So we go out and we collect corals. Sometimes those are what we call fragments of opportunity. This means that are corals naturally dislodged that are not going to stay attached to the reef on their own, so we can bring those in. We also get corals from certain shoreline projects where people need to relocate corals in order to build things. So sometimes we get corals that way, and then other times we have the permits to actually go out and collect small fractions of corals to then reproduce here at the Coral Innovation Hub.
Cool, and that word permit is very important. All of you guys watching, this is very well regulated, controlled, funded. This is a serious operation.
So just to show you an example of some corals that we have brought into the facility, we have shade cloths that cover up our raceways, because it's really important that the corals are not getting direct sunlight. As you can see, our water tables are not as deep as the ocean. So we need to control the amount of sunlight the corals get. So if you can, I don't know if you want to take a look in here.
Yeah.
Some corals. But
Absolutely.
We've got some pretty big fragments of corals here that we were able to collect from here in St. Croix. And so what we can do with these fragments of coral,
So, as you guys know, I love to bring in help for Science Saturday. It's Kenji. Woo! Good morning. So, you're going to be our helper today, and you're going to be helping Lisa cut up some corals. Pretty cool, huh?
So as you guys can see, these kind of fragments of corals are actually made up of a whole bunch of tiny little polyps. You might have talked about polyps before, but corals are actually made up of hundreds of thousands of little polyps. And what we can do is take one of these pieces of coral, cut them up into a bunch of tiny little pieces, and those tiny little pieces will grow very quickly, get a little bit bigger, and then we can actually reattach all of those little pieces underwater to a coral skeleton, to a piece of reef, and they will then fuse back together and be a much bigger coral. So
that is really cool.
Instead of growing a coral from one tiny little polyp that would take 50, 100 years to get big enough to reproduce, we can plant a bunch of these little tiny microfragments, let them fuse together, and in 10 to 15 years we can have a coral that's big enough to reproduce, rather than waiting the 50 to 100 or so that if it was just coming from one tiny little polyp that would take. So
that is really cool.
That's why this is a cool process. And do you want to look at some fragments or make some fragments first?
Ooh, let's look at some fragments to see what we're going to be doing.
So we'll take a look at some corals that we just cut up this past week, and some that we cut up a few weeks ago. So inside here you can see a couple different species that we've cut up. We've got some Pseudodiploria strigosa, which is a type of brain coral. We've got some Orbicella fabulata, which is a star coral, as well as some Montastria cavernosa, a larger star coral, and then some more brain coral, and a little bit of pillar coral under the next shade. So we've cut these guys up, and as they grow big enough and cover up that white plug, then they'll be ready to either fragment down again or plant onto a new skeleton in order to create a new bigger sized coral. So because we're in the like ramping up production part of this, more than likely we'll let these grow out to cover their plug, then we'll cut them into smaller pieces again, put them onto new plugs, and create a whole bunch of corals before we take them out to actually plant them.
So something that I think is really, really cool is even so tiny, you can see like characteristics of what the corals look like when they're much bigger, which is wild. You know, a lot of these are big, like cavern, like the oh goodness gracious, here I go. Montastria cavernosa, really big boulders, but here they are, and you can like see the similarities in like each individual polyp, and it's crazy to think how these tiny little animals make up that huge thing.
Yeah.
Super cool.
And you can notice like some of these guys here with the fresh white plugs were cut just a few days ago. You can still see the scars on the side of them, whereas a lot of these over here have already kind of started healing their scars, and eventually they'll start to grow onto the plug and sheet out.
Very cool. Yeah. We've got a shout out from the crowd. Andrea, hey, says thank you for all you're doing, and thank you for coming this morning, Andrea. We love to hear from you.
Okay, so you guys want to cut up some corals?
Yeah. You ready, Kenji?
Yeah, I am.
Okay. Let's see if I can walk backwards. Production. No, it's not going to happen. I'm going to fall.
So if
Do you have a question?
We're going to go into a pretty small room, so if you can mask up. Also, because we're going to be cutting corals, when you cut the corals, sometimes their nematocysts get aerosolized, and you don't want to be breathing that in, so please wear your mask.
Safety first, guys, for so many reasons. Behind the scenes. This is my behind the scenes song. Okay.
All right. So, in order to cut up corals, we use this diamond blade bandsaw. We also have a tile saw outside that we'll use to cut down pieces to make them smaller. So some of those pieces you saw in the tank were quite large. So I use the tile saw to cut it into smaller pieces, and so I end up with maybe a smaller chunk like this that I can then cut down into even smaller and smaller pieces before I put them onto a plug.
Ooh.
So we're gonna cut this coral up. I'm gonna cut it up on the bandsaw here, and then I'll start dropping fragments into this bucket. And then we will super glue them to the plugs, just aquarium super glue. And then they get dropped into here. There's a little bit of iodine in this water to just make sure that we're keeping them nice and healthy. Going through the fragmentation process is pretty stressful for corals, so we like to baby them a little bit before we get them back out into the tanks. So another thing that happens is when you cut up corals, they put out a lot of mucus. Kind of similar to how you would probably bleed if I cut you up. So they're going to put out a whole lot of mucus, and we don't want that mucus kind of sloughing around, covering them up and causing them any issues. So we have these nice turkey basters that we can sort of suck up some water and just gently sort of blow the mucus off and keep some water moving around the corals so that they are not super unhappy. So, Kenji today is going to maybe help with the basting, if you're cool with that?
Yeah, sure.
Okay, so as we move corals into here or into here, you can squeeze the bowl to suck up a little water, and just these fragments are super tiny, so you're not going to want to like squeeze super hard. Just squeeze super gently to just keep some water moving around them. And then on this guy, squeeze up some of this water, and these ones you can squeeze around a little bit harder. Does that make sense? All right, so we'll cut up a few fragments and then let Kenji do some basting.
All right.
You guys ready?
Ready.
All right.
Safety glasses on, mask on. very cool.
All right, so
Also
I've got a little
terrifying.
piece here that I'm gonna sort of cut down so that he's got a flat base to sit on. All right, and now I'm gonna cut this guy into 2 different pieces.
Very cool. All right, we ready for our basting?
Yeah, you're welcome to do a little bit of basting in there. Just
Okay.
be really gentle because those guys are gonna fly around. All right, we're gonna cut this guy into 2. Okay.
Okay.
All right, we'll do a little bit of super glue in now. All right, you can take a break there, Kenji.
All right, and while you're gluing, we have a question from Andrea. If there is a way to speed up the growth of coral similar to how plants can go under like 24-hour grow lights or anything like that.
Yeah, so this is kind of the way to speed up the growth of corals, right? So if there's like there's a fairly large coral growing, it appears to be growing very slow. So when we cut the corals down into smaller pieces, we kind of increase the surface area of the part of the coral that's growing. So it actually, these little tiny pieces grow much faster than a bigger coral would.
Okay. So it's more about like the surface area than about the conditions and, I assume that being healthy and happy and living in this wonderful facility helps, but not as beneficial as the actual process of microfragging.
I think that good conditions are also very important. And that is something that with the land-based facility you can control those things more than you can control when you're doing this in the field.
Right.
So, we have done this out in the field before, and so we've taken a coral up onto the boat, cut it into a bunch of tiny little pieces. They do this at UBI also. Cut it up into tiny little pieces, put it onto little plugs, and then put them directly back into the water. However, you can't baby them as much, so you can't put them in the iodine bath, and you can't get out there as much to check on how they're doing.
Right.
Right, because you're limited by getting out on a boat and going diving, where when we have them here in the facility, we can come in each morning, check on them, monitor them for disease, which is very important right now in this time of stony coral tissue loss disease. And we are working with species that are susceptible to stony coral tissue loss disease, so we have to be very, very careful.
Right. So you want to make sure that everybody in here is healthy and no cross-contamination and everybody you have in the facility, and when I say everybody, obviously I mean the corals, they're all healthy, no disease specimens have come in.
Luckily, the way that we set up our system is we have basically 4 separate systems. So if we do have corals that have disease, we can isolate them to a specific system, treat them, or whatever we decide to do with them, but we can keep them separate from the other corals.
Okay.
Which is very beneficial because we don't want to be spreading stony coral tissue loss disease
Right.
around.
No.
So we've got a few fragments here, and yeah, does that kind of all make sense?
Yeah. Kenji, any questions?
Yeah. Does the climate of the temperature in the water and around the water, like around the facility, affect the growth of the coral?
Yeah, that's a great question. So in general, corals are very sensitive to the temperature of water. So we have a pretty sophisticated system that keeps our water at 27 degrees Celsius, and that includes actual chillers. So when we have the ocean water, it's not necessarily at 27 degrees, so we chill it down to 27 degrees. Also, when the water sits in these tanks and heats up with the sun, the chillers then cool it back down. So we try to keep the water temperature as consistent as possible based on what the ocean would be during that given season. Very warm water can be very stressful to corals, and they can bleach or release their zooxanthellae, making them appear bright white. As well as very cold water can hurt corals as well. So we're trying to keep that very happy medium of what the water temperature would normally be in the ocean at this time of year.
Very cool. Good question, Kenji. All right. Where are we going next?
Kenji, you want to help me carry these out and we can put them into the raceway? So just a box. You're going to put your thumbs under here. It's pretty heavy, but I think you can probably carry it. We're going to keep the lid on so that these guys don't get any extra sunlight.
All right. Bye, Saw. It was fun. Kenji the strongman carries the box of coral. Aren't you guys glad that I sing everything? Okay. So, if you're just joining us, we are moving the newly fragged corals out into a table.
Alright. That's okay. We'll just set it down to make it a little easier.
All right. Everybody made it? Yay!
Alright. And we've got them labeled so we know what coral they came from.
Oh.
And we can keep a remainder of the parent coral so that we can monitor that coral and these coral fragments. So that if anything were to happen to these coral fragments, if they start to die or look sick, we can check the parent as well and see what might be happening.
So that's really interesting, and not exactly what we were going to talk about today, but now I want to ask, when you're talking about the parents and like we've talked a little bit in the past about like the actual, is it the genomes or genotypes? Yes. Yep.
Yeah, let's talk about genotypes.
Just a little bit, shallow dive into genotypes. So corals are made up of millions of animals, right?
Yeah, so corals, an individual coral, we call a coral colony. And a coral colony is made up of hundreds of thousands, if not more, polyps, depending on how big it is. And the polyps are those little things that look like stars in our star coral, and in the brain corals, the polyps are down in the grooves, and they look like a little sea anemone. But there's thousands and thousands of them that make up this coral colony. Each coral colony is genetically unique, and what you can do, as I was talking before, you can basically break a coral in half and make two corals.
Right.
However, those corals would be genetically the same. They're clones of each other. So when we're looking to grow a whole bunch of corals and we're looking to restore corals, the idea is to make stronger, more resilient corals. And we think that the best way that we can do that is by making as many or as diverse corals as possible.
Okay.
So the more genetically diverse your population is, the more chance that some of them will develop the traits needed to survive. So instead of necessarily picking specific corals for their heat tolerance or their disease tolerance or this, we just want to make as many different types of corals as possible to give those corals the best chance to develop those traits on their own.
Okay. And I imagine that, like you were mentioning in the beginning, the fragment of opportunity, that probably helped, just like going out different places and collecting different corals.
Yeah, absolutely. We do try to vary the places that we're collecting from to get those genetic differences. The other thing that we do in this facility as well is some facilitated sexual reproduction. So sexual reproduction in corals is where corals put egg and sperm into the water, they mix together, they fertilize, they land and create one tiny little polyp. That polyp becomes 2 polyps, becomes 4 polyps, becomes 8 polyps, and continues until it becomes a coral. That takes a very long time, but that is the only way to truly increase genetic diversity, is to have corals sexually reproducing.
Okay.
So we go out to the reef and actually collect that egg and sperm, collect that coral spawn.
It's right over there.
Bring it back into the lab, and we can fertilize it here in the lab. Let it settle out onto plugs or tiles, and actually grow corals on little substrates. Get them through that sort of period of time where they're more likely to just get knocked off or die or anything like that, or get eaten by other fish. So if we can get them to a little bit bigger size, put them back on the reef, then we're putting genetically unique individuals back on the reef as well.
Right. All right.
Yeah.
That's really cool.
Would you like to see some of those tiles?
Yes,
Yeah.
we do.
All right, let's check it out.
Do.
So I'll first show you a couple of corals called Diploria labyrinthiformis, and these corals recently spawned. So we were able to watch these corals spawn here in the lab as well as on the reef. We had divers out on the reef, and we had people here in the lab watching them. And they put out little bundles of gametes, and we were able to fertilize those, let them settle, and let them settle onto things like this. So you can see there's a variety of little substrates that we can let the gametes settle out onto. And they're right now only big enough to see with a microscope. So you can't actually see any of them right here. But we put these structures under a microscope and count them and keep tabs on them. And then eventually we will put them back out into the ocean.
Good luck, everybody. We believe in you.
Yeah.
Very cool. All right, and I see Stormy, you joined us recently. We are in St. Croix at the Nature Conservancy facility at the Coral Innovation Hub. Such a cool name.
Yeah.
Yeah, very cool. All right, so I think that we've done a really good overview of everything you guys are doing here, at least as far as I know.
Yeah.
I mean, this is a lot going on.
Definitely.
So I want to kind of end just talking back to the beginning more about the importance of coral, and just because we had people join while we were doing the demonstration, and I really think that that's a really important message. You know, all of the topics that we talk about on Science Saturday do come back to, you know, not just science, but the environment and taking care of our home. So what's our final thought here?
Yeah, so I like to remind people that growing corals is not going to fix the problems that corals are experiencing. It is it is like one piece in a really big puzzle of protecting and restoring coral reefs. I think even, or just as important as growing corals are things like reducing our carbon footprint to try to reduce the impacts of climate change, voting for leaders who believe in those things and are willing to put forth legislation that can make a big difference in our reduction of our bigger carbon footprint.
Yeah.
Things like that are really big. You know, you can also do things as an individual. All of our beach cleanups and keeping trash out of our ocean is amazing. Thinking about our shoreline development and making sure that we're not letting a whole bunch of runoff go into the water, because even just rainwater heading out to our reefs can be bad. I think as an individual, you've just got to do what you can to conserve energy. You know, you can also like eat a little bit less meat. Meat's a pretty big carbon maker. So just like taking one day a week to not eat meat is a pretty good step to take. And then of course, learning as much as you can about corals. Corals are super important to our islands, and protecting them and providing us with food. So everybody should hopefully be inspired to keep them around for a long time, and yeah, get out in the ocean, go swimming, look at these things.
Yeah,
see what they
absolutely.
Look like, see what they look like face to face. They look pretty cool in our nice blue water tables, but they look even cooler out on the reefs. So
Yeah,
I encourage you guys to
absolutely.
go snorkel and check it out.
Cool. Kenji, time to put you on the spot. What do you think is the most surprising thing we talked about today? On the spot. On the spot. Or what's your take home from today? What's the one thing you want to say to everybody?
Can I ask another question?
Yes, you can ask as many questions as you want.
Does different water types or the growth or climate change affect the tissue growth of the coral that are not in the facility but out in the
In the ocean? Yeah, and the reef? That's a great question. So yeah, climate change can have a pretty big effect on that. So one of the things that climate change is causing is for our oceans to get warmer for longer periods of time in the summer. So the water getting warmer for one day is not always a big deal, but then when the water gets warm and stays warm for months and months, corals start to get stressed. And when corals get stressed, they tend to expel their what's called zooxanthellae, which is a type of algae that lives in their tissue and gives them their color. So without that algae, they appear bright white. But the algae are also a really big food source. So without their main food source, corals can, if they stay bleached too long, eventually starve and die. So that's not great. Also, if corals are putting all their resources into just staying alive, they're not growing as fast.
Priorities.
Another thing that climate change is causing is something called ocean acidification, which I won't necessarily get.
That could be an entire Science Saturday. Joe, I see you signed on. We're going to do an ocean acidification Science Saturday.
But basically, ocean acidification can mean that corals are creating skeletons that aren't as strong. And so if corals are creating skeletons that aren't as strong, they can break easier, and that can have effects on the strength of the reef when a storm comes through and things like that. So yeah, climate change can have a big effect on coral growth and their ability to grow as well. That was a great question.
Very cool. So from the audience, also known as Joseph Townsend, our normal Science Saturday helper who decided to go get his captain's license and abandon us this weekend, wants everyone to know, how can we support what TNC is doing? Other than our personal choices and making changes in our lives, how can we actually financially support you guys?
Yeah, well, you can always financially support TNC. There you can go online to nature.org. We always ask that if you guys do want to make a donation, you make it specifically for the U.S. Virgin Islands. TNC is a big organization, and it's nice to know, or nice to have people be specific about where they want their money to go.
Right.
And USVI Coral is our program. So if you do choose to make a donation, we would love for you to put a little note on there that says U.S. Virgin Islands Coral. In addition to that, our facility is still closed right now due to COVID, so we are not able to bring in people from the public on a regular basis, but that is the goal. Once COVID restrictions kind of loosen up and we become a more open facility, we would love to have people come visit and give tours and things like that. So you can stay in touch with us and find out when that will be. And yeah, we do bring on volunteers occasionally. Just kind of depending on people's interests. We have some interns here from UVI right now that have been really great, and we get visiting scientists. So there's always kind of like a movement of people. So yeah, feel free to get in touch with us. I'm happy to give you guys my email or my contact.
All right, awesome. We'll put those in the comments, and I want to thank you guys so much. Kenji, as always, it's a pleasure to have you come with us when I'm over on St. Croix. Lisa, thank you so much. I'm going to switch around to me again to say thank you, everybody. It's been so much fun to be here at TNC at this beautiful facility this morning, learning about the corals. And a quick shout out, today is my daddy's birthday, so happy birthday, Dad. You know, that's important. So everyone, have a wonderful day. Have a great week. We'll see you next month for the next Science Saturday about who knows what. Bye.